All right, so we are looking at worksheet 1.4, practice A. I'm going to go through how to do some of these systems of three equations. If you're still struggling with that, hopefully this will help. So if I'm looking at number 1, I have three equations, x minus 6y plus 2z equals 5, 2x minus 3y plus z equals 4, and 3x plus 4y minus z equals 2, negative 2. The first thing I see is here I have a z and a negative z, which is going to make it really easy to do elimination on the second two equations. So we're going to start there, and I'm going to take equations 2 and 3 and put them together. So I get 2x minus 3y plus z equals 4, and 3x plus 4y minus z equals negative 2. That's a 2, not a z. And that's 5x plus y equals 2. This is what we called equation 4. Now I have to use equation 1 because I haven't used it yet. 1x minus 6y plus 2z equals 5. And then I need to multiply equation 3 by 2. Now I can use equation 2 and I'd have to multiply by a negative 2 because remember, I need to eliminate z. So if I eliminated z in this equation, I need to eliminate z when I do my second step. So that's 6x plus 8y minus 2z equals negative 4. Let's make sure we did that right. 6x plus 8y minus 2z equals negative 4. And when I put that together, I get it 7x plus 2y, my z's are 0, equals 1. Now that's my equation 5. And it's important at this step to make sure, do I have x and y? Yes, x and y in both equations. If I don't, if I have y and z or x and z in one, then I did something wrong in the second step. I didn't eliminate the same variable both times. So you have to be really careful there. Now I need to put equations 5 and 4 together, so I'm going to multiply equation 4 by 2, negative 2. It won't let me put that negative in there. And so that's negative 10x minus 2y equals negative 4. My menu's in the way. It's not letting me write negative 2 there, but I am multiplying by this negative. Negative, negative, negative. I'm going to add those together. We get negative 3x equals negative 3. Divide by the negative 3. And x equals 1. So I know x, I want to go back to either equation 4 or 5 and plug it in and find y. I don't want to come to the original equations yet because I need two variables to find the last one. So I want to go to my equation 4 or 5. So I'm going to do equation 4, 5 times x, which is 1, plus y equals 2, and 5 plus y equals 2, and y equals negative 3. And then now I can go back to my original equations and plug in and find z. So I'm going to use 2x, minus 3y plus z equals 4. And I'm going to plug in what I know, 2 times 1, because x is 1, minus 3 times negative 3 plus z equals 4. And that's 2 plus 9 plus z equals 4. 11 plus z equals 4. Minus 11. And z equals negative 7. And then my final answer we write as an ordered triple, x comma y comma z negative 1, or 1, negative 3, negative 7. Okay, let's look at number 2. X plus y minus z equals negative 2. 2x minus y plus z equals 8. Negative x plus 2y plus 2z equals 10. It looks like it's going to be pretty easy to eliminate any variable. So let's eliminate y. We're going to have to do the same process no matter which one we do. So we'll combine equations 1 and 2 and eliminate y. X plus y minus z equals negative 2. Okay, and 2x minus y plus z equals 8. So I get 3x, my y's equal 0, my z's equal 0, 3x equals 6. So x equals 2. Okay, well that nicely gives me another one of my answers. So we have a couple options here. We could plug 2 in, or 2 in for x in my equations, then I have y and z. And or I can do elimination again. So I'm going to choose to do elimination again. I'm going to use this third equation, negative x plus 2y plus 2z equals 10. And then I'm going to multiply equation 2 by 2, so I get 4x minus 2y plus 2z equals 16. So I get 3x plus 4z equals 26. And now I know what x is, so I can make that 3 times 2 plus 4z equals 26. And 6 plus 4z equals 26. So 4z equals 20, and z equals 5. And now we can go back to plugging it in. X is 2. So I'm going to plug that into the first equation. X plus y minus z. So 2 plus y minus z, which is 5, equals negative 2. And that's y. 2 minus 5 is negative 3, so y minus 3 equals negative 2. And then we're going to add 3. So y equals 1. My ordered pair, x 2, y 1, 5, or z 5. That's my final answer. Okay, I'm going to let you do number 3 on your own. Can you find the error? It's such an important skill, especially when you are looking at your own work. Can you go back and figure out what you did wrong? Number 4, solving this system. As I look at it, the x's won't be too bad. The y's kind of set up. Let's do the y's. We'll eliminate y. We'll use equation 1 and equation 3. We'll multiply equation 3 by a negative. So that's x plus 4y minus 3z equals 1. And then multiplying by negative, negative 2x minus 4y plus 4z equals positive 12. So I multiplied this equation by negative 1. And let's make sure we did it all right. Negative, negative, positive, positive. Okay, we're going to add it together, and we get that negative x, the y's are 0, plus z equals 13. Now we'll do equations 1 and 3. We'll multiply equation 1 by a negative 3. So negative 3x minus 12y plus 9z equals negative 3. and we're going to add that to equation 2. So that's positive 3x plus 12y minus 9z equals 8. And my variables are all dropping out here, and I get 0 equals 5, which means there's no solution. And I'm done. Number 5, x plus y minus z equals 2, and x minus y minus z equals 2, and 3x plus y minus 3z equals 6. So, looks to me like I should start by adding equations 1 and 2 together. 1 and 2. So, x plus y minus z equals 2, and x minus y minus z equals 2. I get 2x, my y is equals 0, minus 2z equals 4. Now let's see, we eliminated y, so let's do equation 2 and 3, because then the y's will just eliminate again. So x minus y minus z equals 2, and 3x plus y minus 3z equals 6. So you get 4x, the y is equals 0, minus 4z equals 8. One of the things you can actually do is divide an equation to make it easier as well. You don't always have to multiply. So if I wanted to, I could divide this one. This is just to show you something a little bit different. I could take this equation and divide everything by negative 2. And then I get negative 2x plus 2z equals negative 4. And that's by dividing all the terms by negative 2 to make it smaller instead of multiplying to make it bigger. And whenever you have all coefficients multiples of the same number, you can reduce it down as well. You don't always have to multiply to make it larger. And so my 2x and 2x equals 0, and my negative 2z and positive 2z equals 0, and my 4 and my negative 4 equals 0. So 0 equals 0, which means infinitely many solutions. And on the test, we're going to want you to write those solutions into a parametric form. So we'll go back and look at this equation. 2x minus 2z equals 4. And I can choose to solve for whichever variable I want. Say I want to solve for x. So I'm going to add 2z. And I get that 2x, up on me, 2x equals 2z plus 4, divide everything by 2. So x is equal to z, that's a 2, plus 2. So here I have solved x in terms of z. So z is the variable we're going to be using in our solution. If I had chosen to solve for z, then it would have been in terms of x. And it doesn't matter which one you choose. It's whatever one you think looks easier at the time. So that's my x. Z is going to be z. I need to find y. So I'm going to go back to my original equation up here that says x plus y minus z equals 2. So x in this case is z plus 2 plus y minus z equals 2. And I get z minus z. So the z drops out because it's on the same side of the equal sign. And I get 2 plus y equals 2, and minus 2, I get y equals 0. So y actually has a value, and my x in my final answer, x is z plus 2, comma y, which is 0, comma z. And that's my parametric solution to the system of equations. All right, so now for the word problem. 3 bouquets of flowers are ordered at a florist. 3 roses, 2 carnations, and 1 tulip cost $14. 6 roses, 2 carnations, and 6 tulips cost $38. And 1 rose, 12 carnations, and 1 tulip cost $18. How much does each item cost? So we're first going to define our variables. We're going to be very boring and let R equal the price. We know how many were ordered. We want to know the price of the roses. That difference also good, that word of. And C will be the price of carnations. And T will be the price of the tulips. So, in the first information it gives us, it says 3 roses plus 2 carnations plus 1 tulip equals $14. And the next one says 6 roses plus 2 carnations plus 6 tulips costs $38. And 1 rose plus 12 carnations plus 1 tulip costs $18. And we want to know what each item costs. So it looks to me like it's going to be easiest to eliminate the t maybe. Now this is an instance, actually, I'm going to look at this middle equation and I can divide everything by 2. And that might make it a little bit easier for me just to make my number smaller. So I'm going to take this equation and divide it by 2. And I get 3r plus c plus 3t equals 19. Now my numbers are just a little bit smaller, and sometimes that helps. So what I'm going to do first is I'm going to multiply equation 1 by a negative 1, and I'm going to add it to equation 3. So I'm going to get, I'll put it down here in blue, negative, oops, that's highlighter. And, negative 3r minus 2c minus 1t equals negative 14. So I multiply through by the negative. So when you're doing this, make sure you check everything that your distribution is correct. And we get 2 negative 2r plus 10c. My t's eliminate equals 4. And then I need to multiply, I need to combine with this equation here because I haven't used it yet. So I need to multiply by 3, and I think I will also use equation 1. So now I'm going to do equation 1 and multiply it by 3. So times this by 3 now. Negative 3. It's important, I need the negative. So negative 3 times 3r is negative 9r. Negative 3 times 2c is negative 6c. And negative 3 times 1t is negative 3t. And that equals 3 times 14, which is 42. Negative 42. and then I'm going to add those together, and my t's eliminate again. I get negative 6r minus 5c equals, and 42 minus 19, that's 12, 3, 23. And there's no shame in going off to the side and doing the math correctly and making sure you get the right answer. Alright, so now I have 2r and 10c, and I have a 5c here, so I can just multiply this equation by a 2. Then I can put it together, so I get negative 12r minus 10c equals 46. And those cancel out. And I get something that doesn't look right. I get negative 14r equals, oh, this is a negative 23. Okay, I messed that up. Be careful. So that's a negative 46. So now that's negative 42. Now that makes more sense. One, because I couldn't have had a negative price. That wouldn't have made sense. It's not that the price couldn't be a decimal. It's just the price couldn't be negative. And divide by negative 14. So the roses cost $30. Now I can plug that in. Negative 2 times 3. I'm plugging it into equation, this one right here. Negative 2 times 3 plus 10c equals 4. Add 6. 10c equals 10. So the carnations are $1. And let's find out how much those tulips are. 1 rose, so 1 times 3, plus 12 carnations, 12 times 1, plus 1 tulip is 18. And so that's 3 plus 12 plus t equals 18. 15 plus t equals 18. And t equals 3. And so again, this is a word problem, so we want to say in a sentence, the roses are $3, carnations are $1. Oh my goodness, this stylus is driving me nuts tonight. Are $1, and tulips are $3 as well. And that's our final answer. Okay, I feel like number 7 is super easy, so we're going to start with number 8. So I'll let you do number 7 by yourself. Now number 8 is one of those weird situations where 2 of our equations have 3 variables, but the one only has 2. So when we're doing that, we want to make sure we eliminate a variable that allows us to use the first equation. If the first equation only has x and y in it, then I want to make sure my next equation when I do elimination only has x and y in it. So I'm going to eliminate the z, even though that looks like way more work than eliminating the x. Eliminating x is not going to help me at all. So I'm going to multiply the second equation by a 5 and the third equation by a 2. And I'm going to get negative 5x plus 20y plus 10z equals 15, and negative 2x plus 6y minus 10z equals negative 12. Then I have negative 7x plus 26y, the z is equals 0, equals 3. Now I'll combine it with the top equation. When I multiply that top equation by 7, so 7x minus 7y equals 35. And I get the x is 0 out. 19y equals 38, and y equals 2. And then I can plug that back into the top equation. X minus 2 equals 5. Add 2. So x equals 7. And then we'll plug it into negative x, which is 7, plus 4 times 2y plus 2z equals 3. And that's negative 7 plus 8 plus 2z equals 3. That's 1 plus 2z equals 3. And 2z equals 2, so z equals 1. So my order triple, 7, 2, 1. That's my final answer. All right, last problem on this worksheet. Triangle has a perimeter of 90 centimeters. Perimeter is adding up all the sides, right? Write and use a linear system to determine the lengths of the sides L, M, and N. So we know that N plus M plus L equal 90 because that's the perimeter. We know that M is equal to 5n minus 5, and L is equal to 5/4 m minus n. Now, let's see, how do we want to do this? Let's put them all on one side. Let's see what happens there. I'm going to do m minus 5n equals negative 5. And I could probably use substitution, but maybe you don't want to. And then this one is going to be 5/4 m minus n minus L equals 0, because I'm going to subtract L. And then we have the top one, n plus m plus L. Let's see. I can write m plus n, it doesn't matter the order here, plus L equals 90. Now I can do some elimination here. I can add these two together and get rid of it. And I get 5/4 m plus 1m, so that's 5/4 plus 1 over 1. Multiply by 4 over 4 to get a common denominator. So that's 9 over 4m. And negative m plus n is 0, and negative L plus L is 0. So 9/4 m equals 90. Then I can multiply by the reciprocal, 4 over 9 times 4 over 9. And 9 goes into 90 10 times, and 10 times 4, m equals 40. And now that I know m equals 40, I can plug it back into this equation here to find n. So let's see, for 40 minus 5n equals negative 5, minus the 40, negative 5n equals negative 45, so n equals 9. And then I can plug those all back into the L equals equation and find L. L equals 5/4 times 40 minus 9. 4 goes into 40 10 times. 5 times 10 is 50 minus 9. So L equals 41. And is 40 plus 41 plus 9 equal the perimeter of 90? Yes. So now I know L, N, L, and M. I know all the sides. Now it wants to know, is it a right triangle? And L is 41. And M is 40. And N is 9. How can we determine whether this is a right triangle or not? What about the Pythagorean Theorem? If the Pythagorean Theorem works, then it's a right triangle. So let's see. 9 squared plus 40 squared equals 41 squared. If this is true, then it's a right triangle. And 9 squared is 81 plus 2, oops, 1600. I don't know what I was thinking. 1600 equals, let's look at my calculator. What is 41 squared? 1681. So is this true? Sure is. So yes, we can say this is a right triangle. All right, and that wraps up that worksheet for you.